Good afternoon, esteemed colleagues and distinguished guests. I'm Basil Abu Sharh, and I'm delighted to welcome you to our panel discussion on boosting water supply and quality with innovative policies. Saudi Arabia is a water-stressed country. It's actually a very water-stressed country. And at the same time, we are a growing country, growing population, growing economy, growing ambitions, growing industry, and improving lifestyle. And all of this requires water, actually a lot of water. At the same time, we have to secure our food security, and that also requires more water. We are lucky today here and honored to have some of the most important players in the water sector in Saudi Arabia. That includes the desalination sector, the underground water sector, and the wastewater recycling sector. Our guests today are Dr. Omar Ouda, who is an advisor to the Deputy Minister for Water at MIWA. Engineer Tariq Al-Ghifari, he's the Vice President for Research and Innovation at Saudi Water Authority. Engineer Mohammed Abu Haid, he's the President of the Saudi Irrigation Organization. And Thomas Altman, he's VP for Technology at Aqua Power. Today, as you heard, we launched two ambitious missions. One of them is to increase the food supply to 50%, and the second mission is to reduce the cost of water by 50% and to reduce underground water, non-renewable underground water withdrawals by 90%. So doing this requires both policy and innovation, and neither of them is enough. So it's not enough to have policies and regulations to limit the withdrawal of water. And we also need innovations. There's a limit to how much you can achieve with policy and regulation, and that's where innovation becomes essential. So I'll start this panel with a question to Dr. Omar. As a custodian of the underground water resources, which is the most critical resource in Saudi Arabia, you have been able to achieve 10 billion cubic meters per year reduction in underground water withdrawals over the past 8 years. How was that possible? What did you do to achieve that milestone?
Thank you, Dr. Basil, for a good question. But first of all, I want to say that it's my honor to be here, and thank you for everybody to attending this interesting session, and for you specifically to put together a very interesting topic and for discussion. This is a very nice question, and also a very complicated one to answer, and this is coming from where things have started. Before the strategy, before 2017, announcing the National Water Strategy, if we look at the water consumption in the kingdom, agriculture water was consuming around 20 billion cubic meter a year. And in a way or the others, that was about 85% of the total water use in the kingdom. And the big question was for what? How much the return coming to the national economy out of using such a huge amount of water in annual basis, and what is the value added out of this? During the strategy preparation and during setting out the baseline assessment of the water sector in the kingdom, it turned to be that the majority of this water goes specifically for the irrigation of fodder crops, alfalfa, and you name it. That was the majority, the vast majority, around 13, 14 billion specifically being used. And that's for a very simple, I want to give you some numbers. If we look at, like, you name it, any type of crops, tomato or whatever, the annual water used for it is between 15 to 20,000 cubic meter per hectare. Alfalfa, we are talking about 40,000 and above cubic meter per hectare. This is significant, and that's where it starts. That was, a trigger. There's something have to be done there in that specific point. And that's where the real decision, the real decree come out to phase out the fooder cultivation with a certain reducing, with a target to reduce groundwater consumption in the agriculture sector. And that was one of the key reasons to achieve this significant decrease on water consumption, specifically for agriculture sector. But it's not the whole story stopped here. It's coming from a different perspective how this work. One of them that's for the first time, that's in 2022, we have a comprehensive Water Act. And the beauty of this Water Act, that it's classified and mentioned clearly the order of water user, where the priority, the first one have that to meet the human needs, and then coming the industry because it's having the highest return, and then the agriculture. This classification facilitate setting the right regulation to control water consumption and to increase the efficiency of use. Starting within the ministry right now, we have a very comprehensive water meter installation campaigns in the ministry, specifically for farmers' use. That's additional because if you want to control something, if you want to manage things properly, then you have to have the right information about the consumption. And that's added additional dimension to the work coming out to this reduction. Plus, you name it, since there's more control in the abstraction, even big agriculture company like Marai, Nadic, and all these things start to look in a more focused way into their water consumption. They start to try to identify ways to reduce the water consumption. And that's what come out with this result out of many others aspects too. Thank you.
Thank you very much, Dr. Omar. So to put things in perspective, the magnitude of underground water withdrawals the daily is around 40 million cubic meters per day. Now the magnitude of treated sewage water per day is around 7 million cubic meters per day. And the amount of desalinated water in Saudi Arabia is around 7 million cubic meters per day. So you can understand the importance of the underground water sector in the entire water use in Saudi Arabia. Now, my next question goes to Engineer Mohammed Abu Haid, who is the president of the Saudi Irrigation Organization. SIO plays a critical role in the water cycle in Saudi Arabia and in improving the irrigation sector. Can you outline SIO's strategy for enhancing the irrigation water supply and quality, and how innovations is embedded within this strategy?
شكرا دكتور باسل. بسم الله الرحمن الرحيم. I think SIO strategy is built in our strategy is built in the integrated water resource management. This holistic approach, acknowledging the interconnection of all the water management aspects, taking in consideration achieving or based on 5 critical or key pillars. The first one is the infrastructure modernization. As part of our capital program, we are aiming to develop new infrastructure for irrigation across the kingdom, taking in consideration the utilization of the TSE as one of the major water stream to supply the agriculture sector. Not only that, but also taking in consideration the demand of the rural and industrial sector to support the mining, energy sector, and other sectors located inside the cities. The second pillar is the enhancing the water qualities. We are investing a lot, and we do have a major program to construct labs, procure mobile lab, and operating all of that as part of each new infrastructure built utilizing the TSE. You know, the TSE and the manipulation with the TSE water requires a robust and strong monitoring system, ensuring the water is safe and taking in consideration all the parameters of the water are met as per the specification. The third one is the one related to the water management and the side of the demand, or the demand management from the farmer part, or from the farmer perspective. We worked on building platforms to ensure the water allocation for the farmers are based on scientific parameters, agreed scientific parameters, taking in consideration the weather, the type of the soil, the type of the crops, and the season in the year. The fourth one is adopting the climate change, which I do believe the tendency in the region that anticipate extreme events in the Middle East, where our system has to adopt all of these changes in the climate. We started our strategy developing linkage with the National Center of Meteorology to exchange the information of the weather and the anticipated and forecasted climate in the kingdom. The fifth one is the innovative policies. We embrace the new technology transformation, the Internet of Things, remote sensing, utilizing the satellites for the sake of anticipating the water demand, monitoring the water consumption, taking in consideration the rare resources in the kingdom as it is located in arid region. And overall, the objective of the strategy is optimizing the water allocation, not only for the agriculture, but also taking in consideration other sectors, agriculture, energy sector, and industrial. Thank you.
Thank you very much, Engineer Mohammed. This is very enlightening. My next question goes to Dr. Thomas. Thomas, Aqua grew from a local desalination company into a global power in renewable energy and in water desalination. And you have been always very competitive in the water desalination sector, and you managed to be the lowest cost producer in many projects around the world. But this landscape is changing and there is more competition. How are you planning to maintain your leadership in this sector through innovation?
Good afternoon, and thank you for having me here. Thank you for this question. So ACWA Power's journey is very interesting to watch, from a startup to an almost $100 billion company today. And from day one, which I have seen the journey from day one, and I can say even the first 5 people had already innovation in the DNA. And this was very critical for the success of the company. And basically what we have implemented at an early stage was our operation model as open innovation, in lot of collaboration with the innovation ecosystem, which existed only partly at this time, but still I think we contributed as much we could to build and boost it. Our partnership model, leveraging partnerships, was the key. We tried always to bring the right partners and work with them on innovation projects rather than to do everything by ourselves. So the innovation spirit on the open innovation and ecosystem spirit was right from the beginning. But we also understood that we should not just follow what has been done in the past, and we challenged basically legacy thinking, and we embraced change and all the challenges which came with change. And so we turned every stone when we thought about how to cause a paradigm shift and redesigning of technologies. There was a good success story on the way with changing different elements which were just copied from previous projects. We always looked in a holistic view on the project development. It's not only the technology really, it's really how you integrate it. It has a lot to do with the execution, and it has also, of course, to do how to combine the thinking from the design through the execution and mirror that into the operation. So our approach was always not in departmental view, it was always a holistic view on the entire chain from seawater to product water and to the execution. But one of the things we also started very early is to think about what are the people, the kind of people we need. And so it was not like the beauty contest who has the most famous PhD degree. It was really, we need people who have energy, who have curiosity, and who wants to work in a team and really share from the beginning and create a kind of thinking style that everybody will benefit from it. We have a continuous hackathon, if you like, in every project where we form teams and try to find out how we can go the next step in the next project. So people, talent is a key component of it, and we also need to watch in our technology radar. We need to watch what's going on, what is the new ways the plant should consider. We try to avoid the buzzwords and try to think through what does it really mean, because if you follow the buzzwords, for example, currently probably the biggest buzzword is AI, but it costs you a lot of money if you do everything what people tell you can do. So you need to be very forensic and look into it where you really can create value, because our model ends up with we only do projects where we can create an impact. So impact is for us the main result we need. We have a kind of sense of urgency because we are bidding on projects. Competitors, as Dr. Basel say, are not sleeping. They are equally fast on the way. So you always need to try to be one step ahead, and this requires a continuous focus, but not only focus, also prioritization. What you really do. We have limited resources. We are a very transactional company. So limited resources, you need to be extremely focused and extremely fast that you can always accomplish in the next round and the next round to stay ahead of the curve. So I think that's in a nutshell several key components which are part of it, what we're trying to do.
Thank you, Thomas. My next question is for Engineer Tariq. Now, historically, Saudi Arabia managed to reduce the cost of desalinated water. Over the past 70 years, we managed in Saudi Arabia to reduce the cost of desalination substantially. So, and that was done through procurement and through competitive bidding for projects. So the entire world had to innovate and had to push the envelope to reduce the cost of desalination. And where we're at now is extremely competitive. And I arguably say that Saudi Arabia takes a lot of credit for reducing the cost of desalination for the rest of the world. Now, as SWA, and considering the new targets for the cost of desalination through innovation and localizing the innovations that are produced while we continue reducing the cost of desalination. Do you have a roadmap for reducing the cost of desalination by another 50% over the next 15 years?
Assalamu alaikum wa rahmatullahi wa barakatuh. So I'm very pleased to be here today to explain what Saudi Water Authority, and thanks for your question, Dr. Basel. It's just partial of what we do. At the Saudi Water Authority, we focus on the whole value chain. So today we look into the production side, we look into the transmission, we look into distribution, wastewater and reuse. In many different aspects, and how we can oversight it in a way to enable more innovative ideas. But going back to your questions about desalination, I think the maturity level of the water sector in the kingdom is very high, and we can see it increasing time by time. So in terms of R&D, what we have done so far, we've put a strategic approach on how we can enable the innovative ideas or the R&D activities. We have put a link between the academic level all the way to the industrial level, and then linking it back to the incubators in the kingdom and worldwide. For desalination, if you look into the history of the cost, especially when we look into power consumption consists of approximately 60 to 65% of the OPEX cost associated with the desalination, with the production. And that depends heavily on the TDS level in the water. The higher the TDS, the more intense you will be in terms of pumping or utilizing the high pressure pumps, which means more power. So we were able to reduce the power consumption all the way for the big plants to 2.7 contractually. And some of our current plants, we have successfully achieved around 2.35, and thanks to the team who has been putting the effort. And not only that, now we have opened the doors for the private sector as well to reduce their power consumption and adopt the terminology of how we can adopt the latest technologies worldwide. Yet, 2 years ago, when we started to announce our ambition, led by His Excellency, the President of Saudi Water Authority, on how we can reduce the power consumptions and so on, there was a lot of resistance, like any type of industry. But with time now, we see Singapore has already announced in 2025 they will reach to 2.5 kilowatt per meter cubic. In terms of capex, we have done a lot of intensive work in terms of engineering work. When I say engineering work, that starts from the basic engineering all the way to the detailed engineering. What it means is we worked very closely with the manufacturer to understand what is the latest technology that they can implement in a commercial scale to be adopted in our field. And we were able to definitely optimize the engineering, which has impacted dramatically into the capital cost. Not only that, we were able to introduce a lot of local EPC contractor. Back in the days, it was very rare to see Saudi contractors going after mega projects. When I say mega and capital project, these projects we're talking about 2 billion plus Saudi riyal. And we were successful to introduce around 6 new Saudi contractors. Some of them started to do all the development internally in the kingdom. So that's part of the production, just to scan all the chain down the road. We have looked into many different technology into the transmission and how we can implement the right construction into it. Because you have always the manufacturer who, or the manufacturer who supplies the pipeline with certain specifications. Some of these specs are not implemented 100%, so we were able to minimize this. And going down to the wastewater treatment and the downstream, we've mapped into the kingdom the most important technologies that should be adopted, and the conventional technologies as well. Depending where you are in the kingdom, we were able to identify the concept of decentralized wastewater treatment as well as the centralized. and going all the way down to the reuse. And I think it was mentioned by the president of SIO. There is a lot of work that we do side by side with them, especially in how can we treat the water efficiently for the use of agriculture, and how can we resolve it longer time. So instead of having it in 1 or 2 days, we've put a plan now to increase it, and of course we're working with their expertise side by side in general. This is just a brief on the whole water sector and what we think.
Thank you very much. What you described, Engineer Tariq, is an optimization of the CapEx and OpEx of the water value chain, which is starting from desalination all the way to the distribution. And this is definitely innovative business practice. My question is about innovative technologies. Do you have any plans for scouting and adapting and deploying new technologies in Saudi Arabia, and hopefully owning those technologies, developing them here, localizing them, then exporting them to the globe?
Thank you, Dr. Bassel. So when we look into the R&D activities and the adoption readiness of the technologies, we have put a systematic approach rather than just a committee where they sit and pick and choose what they need. We put it in a systematic way where we look into 3 things. The first thing is the number of citations worldwide, the number of IPs, and the number of publications associated with any technologies. And you can look into this in a funnel way. What I mean by that, in a very high perspective, all the way to a narrow perspective. How is that has helped us in the kingdom? We were able to identify where the new technologies are being driven worldwide. So from that, we were able to identify which of them are fit best to our needs. And once those are identified, we start looking into them and investing into them. We have multiple ways of investment when we look into the technology. And that depends on the TRL level, technology readiness level. So if it starts from 1 to 3, we work it very closely with universities. So we give them the time to look into applied research that is of a concern of the industry. And then higher TRL level, we start to work it very closely with the stakeholder. And the stakeholder means the operational companies. And what we do with them, we try to prove it. And once it's proved, Watira is the R&D arm of Saudi Water Authority. So once there is a technology that has been tested fully, we certify this company to be eligible to participate in any tender that the stakeholder put in the market. Not only that, we put them in a program for localizations. And that depends on the interest of the stakeholder. The higher the interest, the more push we will put into the technology. And sometimes we look into a very important vertical in terms of innovation. It's not only about new ideas, because you can look into a sector or an operational company that is not adopting the latest innovative commercial technologies. So we encourage them and we show them the roadmap for it so they can adopt it. And some of the operation company, the maturity level is high, that we need to innovate new ideas that is not being introduced to the commercial market. So once we identify this vertical, we were able to segregate and understand the readiness level of adoption between different stakeholders. Thank you.
Thank you very much. In 3 minutes, we have 3 more questions. So I go back to you, Dr. Omar. Now, this morning you listened to the new missions, which is to increase the food self-sufficiency to 50%, while at the same time reducing underground water withdrawals by 90%. And these look like conflicting missions. So how are you planning to deal with this challenge?
Let me start with that. I believe these are coming from two concepts, sustainability and security, either water security or a food security. Is this possible? Yes, it is. How confident I am, why I'm saying that, it's all completely depend on what Engineer Tariq have said, Engineer Muhammad, and our friend what they mentioned, is development and advancement. Let me return back to the concept, how we operate and setting the right policy for the kingdom. We look on desalinated water or desalinated brackish water plus treated sewage effluent as a renewable, sustainable water source. This concept makes a big difference in the whole story. It is add a significant amount of water to the national water balance, water budget balance. You might come to me, this is a theory. No, it's not theoretical. We have a big plans already on the table. One of them is the National Water Program is optimization of renewable water resources. And when we talk about renewable water resources, it's part of it, integral part of it is treated sewage effluent plus the desalinated water. Additionally, there is the real renewable one in the traditional definition that the whole world knowing about, which is surface water. The kingdom have a plan to build an additional 1,000 dams. And this is mainly, big portion of it will go for food production. That's in one direction. Additional to that, we have already started the construction of 40-hectare pilot farm with the main target to assess based on a farm scale the added value of using desalinated water in agriculture. And this project is right now under construction in Leith in the Red Coast. That's it from the water side. There is a plenty of effort and work already in place to reduce the food waste. And this is a very critical component. A big percentage can reach up to 50 to 60% of food are ended as a waste. And working on that direction, that will help balancing the overall equation. So the whole idea is the balance based on availability and how do we see our resources and how we appreciate it and how we can handle it and have the right target for it. And I wanna use this opportunity just to mention, before this one I was in another workshop talking about a very interesting study which is called Assessment of Total Economic Value of Water in the Kingdom from all resources to all users. And this study aimed specifically to try to value the total economic return from water use by the different sectors in the kingdom toward an efficient allocation of the limited water resources toward meeting national target, including food security. Thank you.
Thank you very much. I go back to Engineer Muhammad. Now, SIO is concerned with utilizing treated wastewater for agriculture. So if you're successful at doing that, you are already reducing withdrawals of underground water by at least 25%. Can you give us examples of policies and innovations that you are planning to deploy to achieve this target?
Well, let me shed the light on the National Water Strategy objectives. The objectives of the water supply and agriculture and the conservative scenario have highlighted the following. In 2016, which considered the base year, the consumption in the agriculture was 21.2 billion cubic meter. That quantity needed to be reduced to 11.2. That reduction in the water consumption in agriculture, taking in consideration 19 billion cubic meter is from non-renewable underground water in 2016, to reduce it to around 6.6 billion cubic meter in 2030. This huge reduction requires policies, regulations, and guidelines, in addition to exploring and new infrastructure to utilize the renewable water resources from surface water, renewable groundwater, and the TSE. So what we have done to achieve that objective by 2030, we have built a portfolio to increase the utilization of the TSE in agriculture to reach 75% of reuse by 2030, from 16% in 2016. If we convert that in quantities, increasing the TSE reuse from 200,000 in 2016 up to daily, up to 4 million cubic meter per day in 2030. We have built a portfolio of $2 billion to construct greenfield infrastructure for TSE reuse, supplying the agriculture, in addition to the parks and rural demand in the cities. From the point of view of policies and regulation, I think what we have done with the Deputy Minister of Water is great. We have established one of the strongest regulation for the TSE reuse, taking into consideration the parameters, limits, the qualities, in addition to the TDS limit provided in that TSE mix. And the awareness side, I think we worked and investing in more than 25 demonstration farms. We selected the major farmers who influence the sector, and we have invested in their farms, bringing new technologies, developing small infrastructure in their farms for the sake of allowing the neighbors and the farmers in the areas to see how the farms should be managed, ensuring the optimization and the water utilization. And the back in the policies and regulation, I think what we have discussed on last Friday, we are working with FAO and developing the Saudi Irrigation Code, taking into consideration the new technologies in the world and the best practices in managing farms, in addition to increasing the irrigation efficiency from 55 in 2016 to reach 75 by 2030. We anticipate to publicize this Saudi Irrigation Code by the first quarter of 2025 as a guideline, then to gradually force it after the coordination with the parties from all the stakeholders. From the innovation side, I think what we have or what we are working currently with the Research and Development Center in King Fahd University and other institutes, and developing the satellite remote sensing platform to forecast the water demand in the agriculture, will inshallah achieve the goal of utilizing the water in a right manner. Generally, these These drivers will ensure, inshallah, and will achieve the national water strategy objective of reaching more than 70% in TSE reuse, and inshallah in achieving more than 75% in the irrigation efficiency.
Thank you very much. For clarification, TSE is treated sewage effluent. So one last question for Thomas. Now Aqua is getting into a new frontier, which is green hydrogen. And when you talk about green hydrogen, then you talk about desalination, sustainable desalination, renewable energy, electrolysis, and energy storage. So without these four components and doing them sustainably, then you cannot have green hydrogen. Two of those frontiers or technologies are still emerging. They are not mature as desalination and renewable energy. So what are your plans for the technology development for energy storage at least and electrolysis?
Good question. Okay, I like the example exactly, the green hydrogen, because for me, it's déjà vu for all my life in desalination before. We started at a certain technology maturity. It was like a very robust and energy-intensive technology, let's say like MSF. And then a lot of work went in, change technology, look at different technologies, reduce energy consumption, reduce chemicals. And so that's what's exactly happening now. We are building now in Saudi Arabia together with NEOM and Air Products, the largest hydrogen project in the world with 650 tons per day. And that's a large project, but our focus is not on this project anymore. For me as innovation, I'm looking in the future. So we are testing already since years alternative methods of hydrogen production, including alternative electrolyzers, but also different ways. Electrolysis has a certain limit, like membranes and osmotic pressure has a certain limit. Electrolyzer have a certain limit, how low you can go on energy consumption. But you can overcome this by looking at different technologies which don't have to split water molecules, which is very energy intensive. And so we're looking into that. But the key is, again, the principles are the same. It's about the integration. We need to integrate the renewable system, which has to be designed for this purpose, not for, it don't have to be designed for lowest LCOE. It has to be designed for this particular purpose, including a high capacity factor. The desalination has to produce a much purer water than normally used here in the country. There is heat in the system which can be utilized. We also have an ammonia system on the backside which has an ammonia loop. There's also heat which can be utilized. So we are looking at, as a developer, we are not looking at one particular technology and trying to develop one technology. We are looking at encouraging the faster development of all the technologies involved, finding the right pieces of the puzzle, and our strength is really the integration of the system and bringing down, at the end it's the cost of hydrogen, at the end it's the cost of ammonia, where we're really focusing on. So we have several pilot plants in operation at the moment, but according to our open innovation model, we work with other companies which have pilot plants in different parts of the world. We don't have to build and repeat everything what somebody's doing, so we are really going there, being part of what other people are doing and trying to bring the information together, to compile it in one place and try to see how we can get great new breakthroughs out of this collaboration.
Thank you very much, Thomas. Thank you very much. I think this is very hopeful. What I heard today is extremely hopeful. I think achieving the missions that we set out is achievable. I think we have the right ingredients. And as we heard this morning, that the United States decided to go to the moon and they allocated all of those resources. To us, the water scarcity is not a decision. It's an essential need that we have to work on and we have to achieve. And I've seen a lot of evidence that it can be achieved. Thank you very much.